So ladies and gentlemen, we're going to work on chapter 11.6, again, graphing a quadratic. So we're graphing quadratics. I'm just going to show you a different way to do it. So before I showed you kind of what we call the vertex form method, where it's in vertex form, and then we graph things moving left or right or up and down, and then we had an A value, okay? Well, now I'm going to show you how to graph these things using something that's in standard form, and we'll talk about using our axis of symmetry and plugging numbers in. So you might need a calculator, might not, depends on how good you are plugging numbers in. So let's go ahead and get started. We're going to accurately graph quadratic functions in standard form. And standard form of a quadratic looks like this, where it's y equals ax squared plus bx plus c. So ax squared plus bx plus c. We should know the graph of a quadratic function is that U-shaped curve. Do you guys remember what that thing's called? Parabola. A parabola. Boom. It says the highest or lower points of the parabola is called its, what's the highest point or lowest point? It starts with a V. Vertex. Okay. And it says if the A value is greater than 0, then it's going to open up. So it's going to look like this. And the vertex is a minimum or maximum point. So if it's opening up, this is a minimum point. So it's either a min or max. That's going to be a min. It's the lowest point on the graph. And if the A value is less than 0, meaning it's negative, then it's going to open down. So I always say frowny face. It'll look like that. And that top point, that vertex, is going to be a maximum or max point for short. Okay, says every parabola can be folded so that one side matches perfectly with the other. The line that divides a parabola into two matching halves is called the, remember what that thing's called that splits it right in half? You guys remember what that's called? Yes, sir. Axis of Symmetry, or I call it AOS for short. So the axis of symmetry is going to cut that thing right in half. Well, that's how we're going to graph this thing, guys. Okay. It says here we're going to find the axis of symmetry using this formula. So there's a new formula today. It's x equals negative b over 2a. Again, the b value is the number in front of x, and the a value is the number in front of x squared. So as I take a look, I'm going to graph this guy right here. This is that parent function that we talked about way back in the first section. We had y equals x squared. In this case, the a value is 1 because it's a 1x squared. And then do you guys see an x term at all? So if you don't see an x term, then the b value is 0. Okay. So as I'm looking to come up with the axis of symmetry, the AOS, I'm going to do negative b over 2a. And in our case, b is 0 over 2 times 1. Well, what's 0 divided by anything, whether it's negative or positive 0? 0. So we end up with a AOS of 0. Okay. Well, now we want to find the vertex. So we have our axis symmetries right here at x equals 0. And we should know that on this axis of symmetry lies that special point, that vertex. Somewhere on this graph is our vertex. Well, all we need to do is plug in 0. Okay. And if you need to, you can plug it into the table. It's kind of whatever you want to do. But plug in 0. What's 0 squared? is 0. So we get 0, 0 is our vertex. You guys okay with that? From there, we should know that there's going to be a part of the parabola on the right-hand side of that axis symmetry and a part on the left. So basically, I want you to graph 2 points on the right and then reflect those over and come up with the 2 points on the left. Okay? So this is where we can just make a table and plug in some values. So what's a value that we can plug in? What's next to 0? 1. So plug in 1, and we know this is over 1 up 1. If I plug in 1, 1 squared is 1. So I get the coordinate point 1, 1. And if I plug in 2, over 2 up, what's 2 squared? 4. 1, 2, 3, 4. We get 2 comma 4. It's symmetric. It's symmetric. So if I plug in -1, I get 1. And if I plug in -2, I get 4. Because it's symmetric. And now I have a nice, pretty graph. Okay. You guys remember about x-intercepts and y-intercepts? X-intercept is where it crosses or touches the x-axis. Y-intercept is the same thing. Could you guys pick out the x and y-intercepts just for fun? If you look at this graph, could you pick out the x and y-intercepts? Where does it cross the x-axis? Or touch it? Yeah, right there at 0, 0.
Would it always?
And what's the y-intercept? Where does it cross the y-axis? What point? Right there? 0, 0. So we'll talk about that from time to time. We're not going to do domain and range all the time, but just a refresher. Domain is always the same thing. How far left does it go and how far right does it go? So again, domain is left to right. Range is bottoms up. So this thing goes all the way to left, never ever stops. This one goes all the way to right, never ever stops. So that's going to be -infinity to infinity. And the range is bottoms up. It starts down here. Where do you see the purple? I don't see it. I don't see it. Ooh, I see it right there. What's this y value? What's that y value? Help me out. Starts at this y value, which is 0. And how high does it go? Does it go up high all the way to the sky?
Yeah.
You betcha. It goes all the way up to infinity. Okay. Now, because 0 is part of the graph, that's going to get a bracket. So we get 0 to infinity there. Not so bad. Any questions what I'm doing? Now, some people don't like using the table. That's totally fine. That's an option for you to do. I always, once I know my vertex is, and if I know my a value is 1, then I follow the normal parabola. Over 1 up 1, over 2 up 4, and that gets me my points every time. If there's an a value, then that's going to be a multiplier to how much I go up or down. Okay? Do you guys have any questions on graphing this basic idea here, using what we call the Axis of Symmetry formula? Negative b over 2a. It's a beautiful thing. Let's try it again. All right, so on this example, I've got a new equation. My equation is y equals x squared plus 3. Right? I always like identifying what's a and b. Hey, what's a? What's the number? Again, when we're talking about these, let me write this standard form. What's the number in front of x squared? What do you guys got? 1. And then is there an x term? I don't see anything, do you? I got nada. I got nothing. So my v value is 0. So I'm going to go ahead and use my little axis symmetry formula. I'm going to use that x equals negative b over 2a. So AOS for short. I'm going to take that negative b, which is negative 0. No problem, Riley. And I'm going to take that 2 times 1 on the bottom. Again, 0 divided by anything is still 0. So x equals 0 is my final value there. Vertex is going to be somewhere on this axis of symmetry line. X equals 0. So somewhere is my point. Now to find that vertex, all we got to do is plug it in, plug it in. I'm going to take 0 and plug it in for x. So I plug that in. I've got y equals 0 squared plus 3. What's 0 squared plus 3, guys? Gals? 3. So I'm going to take that vertex, go up 1, 2, 3. So far, so good. And now I can make a table. Once I have my vertex, I can go ahead and plug in some numbers. If I'm at 0, 3, the next integer over that I would plug in would be 1. Okay, next to 0 is 1, so plug that in. All right. What's 1 squared plus 3? 1 squared plus 3 is 4. Well, doesn't that make sense? That's over 1 up 1 from the vertex. Okay. Plug in 2. What's 2 squared plus 3? 2 squared is what, 4? 4 plus 3 is 7. So that's over 1, 2, up 1, 2, 3, 4. That's just off my table a little bit. Okay, so again, 2 comma 7 would be up here. Here's 7. It's symmetric. Dun 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 dun. Symmetric. Over 7. There's my graph. Well, if you put this all together, that looks pretty darn similar to what we just did, right? What we did yesterday was we took this value and said, well, this is just my parent function shifted up 3 units, right? So we went up 1, 2, 3. There's my vertex. This is just another way to graph. Come up with the axis of symmetry. You know the axis of symmetry's got that vertex on that line. Plug that in and you can find it. Okay? All right, for fun, x-intercepts, y-intercepts. X-intercept, does it cross the x-axis at all? There is none. Y-intercept, there's definitely a y-intercept. What's the y-intercept? 0, 3. And then let's do domain and range one more time. Domain, x's, will always be negative infinity to infinity if they ever ask you that. I don't think they do, so that's why I'm not going to make a big deal about domain or range. It's a good thing to review it. Range is your y's, bottoms up. Don't see it, don't see it, don't see it until this y value. What's that y value? 3. So it starts at 3, bracket, goes all the way up to infinity, never stops. So final answer, I get y equals x squared plus 3 gives me a domain and range of this, and a nice pretty looking graph. A couple more, because I really want to try to get you some time to work. That way you can ask some questions in class on the My Math Lab stuff. All right, let's definitely do number 3. Again, we're going to spend 2 days at least on this stuff. So let's take a look. I've got y equals 1/2 x squared. Again, a value this time is 1/2. And again, there is no b value, it's just 0. So in this case, AOS, I have negative 0 over 2 times 1/2 this time. But again, what's 0 divided by anything? 0. So far, so good. So my vertex is going to lie somewhere on this axis of symmetry, x equals 0. Somewhere on my vertex is on this line. Oh man, it's Friday, sorry, getting a little goofy. Find the vertex. It's 0 comma something. Plug in 0. Plug in 0 right there. So what is, I got y equals 1/2 0 squared. Please excuse my dear Aunt Sally, square it first. What's 0 squared? Times 1/2. 0. So this thing's not moving anywhere, right? It's just staying right there at 0, 0. Now, if you're following the little rule of over 1, up 1, over 2, up 4, that's awesome. But don't forget to multiply by the a value. So again, we have an a value of 1/2. Okay, so the idea is if you're doing that and you're not using the table, that's over 1, up 1 times 1/2. Well, what's 1 times 0.5 or 1/2? 0.5, so you're only going up half of a box. Now, normally I go over 2 up 4. Well, it's now 4 times 1/2. What's 4 times 1/2? 2, so I'm only going over 2 up 2 now. Okay, now, if you don't like that, make a table. Plug in 1. So then you have 1/2, and then 1 squared is 1/2. 1 squared is 1, and then 1 times 1/2 is 1/2. Plug in 2. So you have 1/2 times 2 squared. That's 1/2 times 4. Well, that's 2. Half of 4 is 2. Okay. It's symmetric. You can plug in more values if you want. You can plug in 3 or whatever. That's going to kind of take you off the chart. So, I got a nice looking graph. X and Y intercepts. X-intercept, Y-intercept, same thing, isn't it? 0, 0, Michael says. Boom. So if they do ask you X and Y intercepts, you should be able to look at the graph and identify what is the X and Y intercept. All right. Domain and range, we're good with it, right? All right, I'm flipping over. All right, definitely want to do at least 2 of these last ones. You said 5? Or do you want to do? Yeah, either one. I want to do, let's do 4 kind of baby steps, and then we'll do either 5 or 6. We'll do 4 and 5. How's that? Makes it easy. And then we'll leave off 6. I'll put it on the notes though for you to look at if you want to see them. All right. Hey, I got an A value, guys. What's the A value? -2. So the thing that I'm seeing there, first off, it's negative, so I know this is going to be a smiley face or frowny face. Frowny face. And that goes back to if A is less than 0. Oh, it's so sad. Also, A is, bigger than, it's bigger than 1. It's 2 or 3 or 4, or -2, -3, -4. It's going to be stretched also. So I got to remember that. The B value, there is none, which is 0. So if you're following with us at home and you don't have your packet, we're graphing y equals -2x squared. All right, go ahead and plug that in for your AOS. X equals -b over 2a. Plug in -0 over 2 times -2, and we still have an AOS of x equals 0. A little dashed line when you graph this on MyMathLab. Plug in 0. Guess what we got? What's negative 2 times 0 squared? What's 0 squared times negative 2, y'all? 0. 0, 0 is my vertex. So that thing did not move at all. All right. Now for me, I always just use I never use a table. I don't like using tables. It's an easy way to make mistakes. I just do it in my head. I'm also a math nerd. So I do this stuff on the weekends. That's what I'm going to do all weekend, is just work on graphing these things. So for me, I always remember it's over 1 up 1, over 2 up 4, unless there's an a value. In this case, I have an a value of negative 2. So now it's over 1 down because it's negative. 1 times 2. Well, 1 times 2 is 2. So I'm going to go down 2. Down 2. Okay. And then I usually go over 2 up 4 because 2 squared is 4. But now it's down because it's negative. And it's 4 times 2. So I'm going to go down. What's 4 times 2? 8. So I'm going to go down 8. So 7, 8 negative is way down here. Way down here. And the nice thing is when you're graphing on MyMathLab, I think you need the vertex and one other point. And then you have a nice, pretty graph. So once you go over 1 down, you're good to go. Okay. So almost, when you're using your little slope tool, it's almost like your little parabola tool. That a value is almost like positive you go up, negative you go down, and then that's how many blocks you go up or down. If it's negative 2, I go down 2 blocks. So over 1, down 2. If it's 1/2 or 1/3 or whatever, that's how much I'm going up. Again, some people like to plug numbers in. That's fine. So that would be negative 2 times 1 squared, which would be negative 2. And that's what we have is 1 negative 2. If you like plugging in 2, that's negative 2 times 2 squared. That's negative 2 times 4, which is negative 8. And that's why we graph this one right here. Just in case you do see this, I want to make sure you be able to answer these questions. So x and y intercept, where does it cross the x-axis? Where does it cross the y-axis? And y'all would say same point right there. You guys okay with 0, 0? X and y intercepts? Questions on why that's it? Okay. Let's do one more. Last one. Any questions on 4 before I move on? I feel like I'm going super fast. No? Yes? No? We're okay? Okay. All right. Last one then. I've got example 5. So if you're playing at home and you don't have your notes, it's y equals negative 1/2 x squared, negative 1/3 x squared, and then minus 2. Okay. A, I've got negative 1/3. And B, what's B? Is there an x term? No x term today. That'll be Monday's lesson. Okay, so I have my B value of 0. So again, I have negative 0 over 2 times negative 1/3, which is still 0. So axis of symmetry, x equals 0. Well, now I want the vertex. I know the vertex is at 0 comma something. And I like to use the cover method too when I'm plugging in 0. Plug it in. Look at what I'm left with. What's negative 1/3 times 0 squared minus 2? What does it simplify to? Cover up your x's. What are you left with? -2. Okay. So that's one thing you should always know is that, you know, if you have an x value of 0, cover up all your x's, cover up method. There we go. We got 0, -2. Right there. So again, my vertex is always on that axis of symmetry. If you know the axis of symmetry, plug it in, plug it in, plug it in and find it. All right. Now we need to find another point, right? We need to graph this thing. So I'm over here. I see it's negative, so I'm thinking frowny face for a value. So I'm going to go down. How much? So over 1 down. How much of a box? 1/3 of a box. Over 1 down 1/3 of a box. How much is 1/3 of a box? I have no idea. About 1/3 of it. 0.33 of a box. If you want to do the next one, I would go over 2. Now I'm going down. 4 divided by 3 is 4/3. 4/3 is like 1 1/3 of a box. So I'm going to go over 2 and then down 1 1/3. 1 1/3. Now that's kind of tricky because of that fraction of 1/3. So again, you can always plug that in. I plugged in 1, and then I did -1/3, 1 squared, and then -2. 1 squared is 1 times -1/3. That's -1/3, and then -2 is -2 1/3. And that's what we have. So it's down 2 1/3 of a box. Again, if you're bad with fractions, you can always do that with the calculator if you need to. Okay, if I plug in 2, that's -1/3 times 2 squared minus 2. 2 squared is 4 minus 2. That's -4/3. I would just make that -1 1/3, just reducing to a mixed number. That's 3 1/3. So I went over 2 and then down 3 1/3 of a box. Not quite to -4. Nice thing is when you're graphing these, you only need the vertex and one other point. That's the nice thing about MyMathLab. Make sure that's solid on MyMathLab, and then this guy's got to be, the axis symmetry's got to be a dotted line. I was messing around with that, messing that up yesterday when I was testing it out. So watch out. And guys, that's it. That's the first day. Most of your B values should be 0. If they're not 0, we'll talk more about that on Monday.